For this lesson, we're going to learn about the Pythagorean Theorem. So first of all, we need to know about right triangles. And a right triangle is a triangle that has a 90-degree angle. And then you see the symbol for a 90-degree angle. It's going to have like a little square in the corner of the angle. So you're looking for an angle that has a little square in the corner. And that tells us it's going to be 90 degrees. The Pythagorean theorem only works for right triangles. And that is going to be a squared plus b squared is equal to c squared. A and B are called the legs, and C is called the hypotenuse. And the hypotenuse, side C, is always going to be the longest side. Every time. And it will be right across from the right angle. So we'll make that symbol for right angle. So side C is always going to be across from the right angle. We could also make notes and use this side over here if you want to make more space for that. So the hypotenuse always the longest, always across from the right angle. And then we can draw a picture of that too. So if I have a triangle, and we'll have a right angle in the corner, right across from the right angle, so across from the right angle, this would be C, the hypotenuse. And then for A and B, the legs, it doesn't really make a difference. One is A and one is B, and it doesn't make a difference which one is which. The only one that has to be is C, has to be the longest side, which is across from the 90-degree angle. And then with the converse to the Pythagorean theorem, kind of like doing the Pythagorean theorem backwards is the inverse of it. And for this, we're going to use the Pythagorean theorem We're going to use Pythagorean theorem to prove a triangle is right. Because if Pythagorean theorem works, then we know it has to be a right triangle. So we're going to start off with the regular Pythagorean theorem. And in numbers 1, 2, and 3, that helps us out a little bit. It kind of gives us a letter. It gives us that this is side C. If it didn't, we would know that it is because it's across from that 90-degree angle. So then one of these is A and one's B. Doesn't make a difference which. Then I'm just going to plug those into Pythagorean theorem. So A squared, and A is 35, so 35 squared, plus B squared, so that's 39 squared, is equal to C squared. There's always going to be one that we don't know. That's why we're trying to solve it. I'm going to go ahead and square those numbers. So 35 squared is 1225 plus 39 squared, and that is 1521. And then we've got that plus sign there, so I'm going to then add those two numbers together, and we get 2746 is equal to C squared. And then just like we did in an earlier lesson, I want to get that C by itself, but it has a square. The opposite of a square is the square root. So then we would square root both sides, because that's going to cancel each other out to give me just plain C. And then we take the square root of 2,746, and I'm going to round to the nearest hundredth. It's going to be 52.40, or 52.4 if we round to the 10th. We'll repeat for number 2, except for number 2, it is the side B that we're missing. Again, just in case we weren't told which one's A, B, and C, we know that the 67 is C because it's across from the 90. So we know that this is side C. And if they're calling this one B, then let's call this one A. So then I have A squared, and A was 58. So 58 squared plus B squared. We don't know B, so we just say B squared is equal to C squared. And it says C is 67, so that means that's 67 squared. I'm going to go ahead and do my squares. So 58 squared is 3,364. Can't do anything with B squared yet. Then I can do 67 squared. And 67 squared is 4,489. Now, unlike the last one where there is a plus sign in between the two numbers, this one we have to solve the equation. We're trying to get B by itself. So we need to move the 3,000 over to the other side. To do that, we use inverse operations. So then that's positive. We need to be negative minus that number because that's going to give us a 0. And what I do to one side, I've got to do to both sides. So I'm going to subtract the 3,364 from that. And that is going to give us 1,125. And then I still have to take the square root of both sides to get that B all by itself. So the square root of 1,125 round to the nearest hundredth is 33.54. And then we'll repeat again for number 3. This time it's A we're missing. But again, remember that if it didn't tell us, we go across from the 90 degrees, and that means this has to be C. And if they're telling us this is A, then that means this must be B. Again, A and B doesn't make a difference. The only one that we have to have is C. So this time I don't know A, so that just stays A squared plus B is 16, so 16 squared equals C squared, which is 45, so 45 squared. Then I'm going to go ahead and square the numbers that I have. So that's A squared plus 16 squared is 256. And 45 squared is 2,025. And then again, we have to solve an equation because we don't have that variable by itself yet. The variable has to be by itself before we can take the square root. So opposite of plus is minus 256 on both sides to make that go away. So it's going to give me my A squared. Now we have that A squared by itself, which is what we needed. And that's going to give us 1,769. Now we can take the square root that variable is all by itself. And A equals, take the square root of that number. Rounded to the nearest hundredth is 42.06. So depending on what numbers you have, like in number 1, we had the plus sign already between the two numbers. I can go ahead and add. When we didn't have the plus sign between the two numbers and it was the variable, we had to do some simplifying or solving of an equation first. The next set of directions says determine whether triangle with the given sides is a right triangle. So we don't know that it's a right triangle. We're going to use Pythagorean Theorem to see if it is. So we're going to plug everything into A squared plus B squared equals C squared. So in this first one, we're going to have 13 squared plus 8 squared equals 21 squared. So I'm just plugging in my A, B, and C. Then I'm going to square all those numbers. So it's going to be 169 plus 64 plus 441, or sorry, equals 441. And then the two numbers on the left, since there's a plus sign in between them, I'm just going to take the 169 and add that to the 64. And we get 233. On the right-hand side, we still just have the 441. Then we have to check, are these two things equal? Is 233 equal to 441? And that is not equal, which means this is not a right triangle. Because Pythagorean theorem did not work, which means it's not a right triangle. We'll do something similar for 5. We're going to plug in A, B, and C. So that's 24 squared plus 31 squared is equal to 38 squared. Now for us, it's telling us which one's A, B, and C. If it didn't, you would just need to look at which number is the biggest, and that number would have to go in place of your C. So I'm just going to square everything. 24 squared is 576. 31 squared is 961. And 38 squared is 1,444. Then I'm again going to take the 576 plus the 961 that are next to each other there. And that's going to give me 1,537. And does that equal to 1,144? And again, this is a no. So this is not a right triangle. And then for our last one, we'll do the same thing again. Plug in a Pythagorean theorem. So a squared plus b squared equals c squared. Then we square our numbers. 57 squared, 3,249. 76 squared is 5,776. And 95 squared is 9,025. Then I'm going to go ahead and add up the two numbers that are together. The 3,249 plus 5,776. And we get 9,025. And on the right hand side we still have 9,025. And in this case they are equal. So this one is a right triangle. So if Pythagorean theorem works, it must be a right triangle, like in this last one. Or if Pythagorean theorem does not work, like in numbers 4 and 5, then that's because it's not a right triangle.